Hello. So this is meant to be a tutorial series. I'm going to split this into 3 parts, explaining how to do Bezier curves in Unreal Engine's blueprints, and really just like understanding the concept behind how a Bezier curve is made and everything at the beginning. There's going to be 3 parts to this, 3 different videos. The orange one is going to show an example of the one we're doing for this video. Blue one is going to be the second part, and then the purplish pink one is going to be the one for the third. It's going to be multi-part. All 3 of them basically use the same sort of Bezier curve. The other 2 just have it slightly modified to support like more than 3 points kind of thing. This one has 3 points where it's a curve. You have a start, end, and a control anchor. This one has 2 control anchors, if I draw the curve. And this one uses multiple as an array kind of thing. This is not really meant for like full gameplay implementation unless you find a reason to use it. It's for educational purposes. What else? Oh yeah, it's also only using vectors. We're not using transforms. We're not meant to really deal with the rotation stuff. I show a rudimentary example of like getting the rotation stuff in there. If I hit play, it's basically what's happening. And the way it's doing is just based off of velocity inside of the arc, essentially, inside of the Bezier curve. So first we're going to start on the orange one and how that's made. So I'm going to go, I also deleted the skybox in the example maps just to show you. And I'm going to show you how to do the rotation, showing the arc spline debug mode, and just making it move across it kind of thing. So inside of my little template map, there's nothing in here, just, generic third-person template. I'm going to create a new actor by right-clicking and blueprint class, actor, BP underscore simple Bezier. And we're going to open this up. We're going to add a cube. And we're going to turn off collision just because. And we're going to add arrows. This is going to be our forward. I'm going to hide it, unhide it in game. And then we're going to duplicate and name that right. And we're going to change its color to green. And rotate it 90 degrees. And then we're going to do that again, but with forward again, and we're going to name it up, change its color to blue, and rotate it 90 degrees up. Great, so we got our arrows, we got our cube. Go into the event graph, delete these nodes, we don't need them yet. I'm going to turn off tick on this, but we don't need that. And I'm going to add a timeline. This is just for, just for the example purposes. I'm going to name it timeline underscore lerp. I'm going to open it up. I'm going to add a float alpha float track. I'm going to name the track time. I'm going to add 2 keyframes, one at 0, 0, and then the other one is going to be at 1 and the value of 1. And I'm going to use last keyframe and zoom to fit. Just click on last keyframe. All right, so some basic setup is done. Now I'm going to explain the concept behind the Bezier curve, essentially. So the way the curve works is we give it 3 points, all right? And this is a simple version. Ignore like the moving lines and graphs or dots and everything. Just focus on point 0, point 1, and point 2, okay? So if I go here, I'm going to drag my simple Bezier in, drag this up. I'm going to add 3 vectors actually. So I'm going to name this one start, name it vector. Add 2 more. This one's going to be control anchor, and another one end. And we're going to make them instance editable, show 3D widget. Instance editable, show 3D widget. You don't need the start one to do that, but I'm just saying you don't need to start for now for this example. If you want to, you can in your project or whatever. It's up to you. This is just for example purposes. So I'm going to move this 500, 500, and 1000. All right. And this is why I had the sky sphere deleted so I could see these. So let me move this over and get our example back up. All right, so in this case, 0.0 is this one right here, our cube. 0.1 is our control anchor up here, and 0.2 is our endpoint over here. What we're doing here is we're feeding in time, which is 0 through 1, and we're lerping from 0.0 to 0.1, from the cube to control anchor, and from 0.1 to 0.2, control anchor to end. And we're doing it separately but at the same time. So when we do that, we get two vector locations, which are those green dots. So when we're lerping between 0 and 1 on the points, we're getting this green dot on the left side, and it's traveling along with like time. So it's the same process with 0.1 to 0.2. We get another green dot, it's traveling, and they're both we're both getting them at the same time. So that's why they're moving at the same time, is because we're feeding in the same value for the lerp at the same frames. So that's why they're traveling at the same time. And if we lerp between those two green dots, we get the curve essentially, because those lines are essentially just like the distance between them. It's the same case with P0, P1, and P2 kind of thing, where it's just distance between them, and we're lerping between each dot and then getting another dot from that, and then lerping between those dots that we just made. And that's how we get our Bezier curve. So let me drag that over here. So we're going to do that in code for getting our line from here to here and here to here. So I'm going to make a new function. I'm going to name it getLocation Bezier. And for input parameters, we're going to do three vectors and a float. All right, the float is going to be time, and then the vectors are going to be our start point, anchor point, and end point. Okay. And then we're going to return a vector. I just named it return value. We're going to make this function pure, since we don't need input parameters outside of it, or input pins, or execution pins. And from here, we're going to do a sequence to make the code clean. All right. So based off this, first we need to get our P0 to P1 lerp. So all we have to do here, drag out of start point, lerp, and plug B into anchor. And then alpha is going to be our time. And what we're going to do here is we're going to right click, promote to local variable, and we're going to name it temp A. Connect that to that. And we're going to do the same thing where we duplicate, get our lerp, plug in alpha. But in this case, it's going to be from P1 to P2, which is going to be anchor to endpoint. So we're going to plug anchor into A and then B into endpoint. As you can see, anchor gets used both times. That's fine. All right, so we're going to right click, promote to variable, and it's going to be temp B. All right, so we're going to duplicate the lerp again. So now temp A and temp B are little green dots. So let me get that over. So temp A is this green dot on the left as it's traveling, or as it's lerping up. And temp B is our green dot that's traveling down from point 1 to point 2. So we plug our return value to this for the lerp, plug in our time, and we're going to use temp A for A and temp B for B. And that will give us our little black dot that's moving across in an arc using these lerps. Math is pretty fun, huh? All right, so what we're going to do is we're going to drag in our get location Bezier, and we're going to plug in time into time on our timeline. We're going to drag out up of update. We're going to do a draw debug line first, and then we're going to drag out of this and do set actor location and rotation. I'll show you how to do the rotation next. So we're going to plug our return value in a new location, turn on teleport. So what we're doing here is we're setting the location in an update frame sort of method, because that's how timelines work. So, or a tick, method way. So in our draw debug, we haven't actually updated our actor's location yet because it happens after we draw the debug line. So we can use our current actor's location. What we can use is his current location as the start of the line, and then the endpoint is going to be where we're sending him, or it pretty much, because it's a cube. And we're going to change the color to pink, and the duration, let's say 5 seconds, and the thickness will be 2.5. All right, so now we need our start and endpoint. So I'm going to plug in start, control anchor, and endpoint. All right, so now that that's all set up, let's set up our rotation function. So it uses the same input parameters, except the return value is different. So I'm going to just right click on the function and select duplicate. And we're going to name it get rotation Bezier. All right, we're going to change the return value to a rotator. And we're going to delete this, because it's going to be different. So the way I did it is meant to be just a simple kind of like explanation on the fact that you control what the time value is. So you already have all this sort of pre-calculated ahead of time. You just need to grab it, a snapshot of where it is on that certain timeline along those lines. So it's a really powerful tool, really, to understand that. So what we're going to do is we're going to drag get location Bezier. I'm going to connect these. I'm going to right click return value, promote to local variable, and we're going to name it temp underscore current. And we're going to delete temp A and temp B from this function. So this is our current frames calculated out Bezier location along the curve. So we're creating this curve. So focus on the red line. So we're creating this curve. Let's say it's at 0.2 right here kind of thing. What we're going to do is a velocity method where we use either the previous frame or the next frame to calculate the direction that it's going in. And then using that, we're creating a rotator from it. And that's our rotation. That's the simplest way I can explain it, really. So I'm going to do a branch. And in here, we're going to actually do our estimates. So we're going to add to our time. And we're going to give it a really small value. But what we're going to do is we're first going to try the backwards method where we use our previous time. So negative 0.001. And what we're actually going to do is we're going to check if it's in range of 0 through 1. Because if it's outside of our arc, if it's outside of our time, there's no reason we can continue or anything like that. So we have to check for that. And if it's not in range, then we try the opposite method where we check in the future. So right now we're using the past location in the arc. And then if it fails, like if we're at 0 and we add negative 001, that's going to be in the negative values, then we're going to try in the future and check to see if what the direction is from 0 to that. And this avoids it from like flipping in the wrong direction kind of thing. So I'm going to drag this over. Sadly, we'll have to do this again. And we'll have to do it again for the future version. So first we're going to do the past version. So let's comment this. Past on curve. And we're going to grab our temp current and subtract them. This will create a line from our previous one to current. And normalize. And we're going to plug this into the return value, which will make the rotator for us. And there we go, we have that. So I'm going to duplicate it, bring current back down. This time current is going to be under our future point. Future on curve. Oh, I just realized, sorry. Past should be plugged into this, since that's what we're adding to it. Our, time that's estimated. And then for future, we're going to plug that into there. And instead, it's just going to be a positive version of 0.001. And plug that into there. Future on curve. And like so. And there we go. We have our rotation. There you go. All right. So we're going to drag our get rotation in there. And we're going to do the same exact thing. Start, anchor, end, time, and return value to here. All right. So if I go to begin play. So one thing to let you know about, these are currently in local space. So we need to transform them from local space to world space. To make that easier on ourselves in the future as well, using this as an example, we're going to make a function, update to world vector, and we're going to make the input parameter a vector, and we're going to pass by reference, and we're going to name it in vector. Okay, so we're going to drag this, set by ref. So this is the only way we could actually set those variables without having to like drag them in individually and do set kind of thing, which makes life much easier. So next we're going to do is get actor transform. Drag this out. Transform location. Sorry, I was trying to remember the name of it. And then plug in location to our in vector. This will create a copy of it. It will not directly edit it because the symbol they use for copies are these these little circles, and the symbols for references are these little triangles. You can't get references of objects though, just structs. Yeah, so all we're doing is we're converting it from local to world space, and that's it. So then for our start location, we know it's going to be at the actor's location, so get actor location, plug that in. And then what we're going to do is drag in these functions for control anchor and end. Like so. And now we're going to play our timeline. But first, let's give it a delay. And then we're going to drag our timeline component, play from start. And if I hit play or simulate, it does the arc, and it shows our little arc as well. So, yay. So now, how do we show the arc inside the viewport so we can actually like debug and look at it and just see what's happening? So to do that, we're going to make two functions. One is called draw curve. And this is going to be our button in the editor, just for telling it to draw. And then we're going to make a new function for draw curve for seconds. And this will have an input parameter of a float. It will not be a pass by reference. And we're going to name this in duration. And the seconds will be in 2 seconds by default. So if we go back to draw curve, compile, save, drag in our function for draw curve for seconds, and then when we call this, select the function and make sure call in editor is checked. If we go back to the viewport, we have our button, we can call it. Right now it doesn't do anything, but we input a parameter for duration. This allows us to reuse this function anywhere else without like messing with the editor stuff. So we know this is being called while in the editor. We know this is happening just anywhere probably. All right. So now what I'm going to do is I'm going to get the actor location. All right. We're going to promote that to a local variable. I'm going to name it temp debug start. So remember how inside of our rotation function we were just simulating like probably like a frame or so of like time in the future or in the past? What we're going to do here is we're going to simulate the whole thing in a while loop. So we're actually going to add another local variable, name it temp time. I'm going to make it a float value. Compile, save. We're going to drag in and do in range of 0 through 1. Drag out of this, while loop. And then every loop iteration, we're going to increase that time value by a little bit until it's no longer in 1 or in 0. So we're going to drag out a loop body and do a sequence to make the code clean. And we're going to duplicate this and add a plus. And time can only go for, we know time's only going forward, and plus, you know, debugging and stuff like that. So we know it's going to be, we're just trying to get the arc. So we're going to use 0.01 as our debug time. So that way it's not like too small where computer locks up just thinking about it, or too many iterations. And then we're going to set time to that value and connect that here. So it happens after we do our debug showing and stuff like that at the end of the loops. Let's also comment this. Let me comment. Simulate the increase of time while in the while loop. I just realized while in the while loop. Yeah. That probably grammatically sound better. It's repeating self. Anyway. So next what we're going to do, we have our debug start, but we're going to be refreshing that so that way our start point for the draw debug line is what we're going to do. So draw debug line, and we're going to change the color to red. Duration, let's drag it to our in duration. The thickness is going to be 2.5. So we have our debug start. Then what we're going to do is we're going to set it again right after to our new like time that it's going to be at for this loop body frame. To do so, we're going to right click, promote to local variable, name it temp debug end. Drag that. And we're actually going to be setting it, and then we're going to directly be calling this right before it, kind of thing. So do that. And now to actually set the value that's going to be like our point on the arc at this time, kind of thing, in the loop. So we're going to drag and get location Bezier. We're going to get our temp time. And we're actually going to be using our start point, control anchor, and end point in local space here, because after we've calculated the location on the arc, we just transform it out from local in the world space here. So get actor transform, transform location, plug that in, plug that into our debug end, and there we go. All right, so that's ready to go. If I go back into the viewport and click draw curve, we are simulating across like our while loop, we're simulating time, and every time this function gets called, it gets reset back to 0. So when it's basically in 0, and then it goes, okay, I'm going to get the Bezier curve at 0, get the endpoint, and we know our start point is our active location already before we go into the while loop. If we do it after we start the while loop, then that's going to be a problem because it's just going to be in the same spot. Then we feed in our Bezier curves values that we're actually using, which are control anchor, end, and start point, and we just transform it from local into world space. That's our point that we're going to show it inside of the world kind of thing. Otherwise, it would be local and like probably around wherever 0, 0 is. And we're going to draw it from start, which is our actor location, to the time. So it's going to be at the time of the Bezier curve in 0. And then now that we've gotten that, we update our start point to be whatever our current Bezier curve point is. And then we update time to increase. Next loop body at 0.01. We get the location on the curve. Do that again, and then update our start point to be that location on the curve that we did before. And it just repeats and repeats and repeats. It's really nice until we run out of time, which is 0 through 1. And if you do it smaller, it also can do better resolution through that, the more iterations that it has, but I think Blueprint has a maximum count of iterations. I haven't run into it yet, so, good luck. So now we're going to go into the construction script, press B to add the branch. Then we're going to add a variable, promote to variable, B debug curve construction. And this will be for like updating it in the editor while we're modifying it to see what's happening. So compile, save, and turn this off by default. And then we're going to do draw curve for seconds again. And we're going to change the time to 0.02. Because if we put it to 2, while we're modifying stuff in the construction script, it will be running constantly, because that's how construction script works. So if I checkbox this, and then if I modify control anchor, look at it, it moves, changes it. Woo! And you can call draw curve, and it does it separately, so that way you can see where you changed from. It's very helpful. So if I do this, hit play, there it goes. And of course, you can do whatever. I'm just doing it on the X and Y, or X and Z plane just to show you, but here's in 3 axes. There you go. Nice and fun. Little smiley face. So yeah, that's how you do a simple Bezier curve. I will be making part 2 and part 3, where you have more than just 3 points really, and then showing you like how to, build out your little debug and stuff like that. We can actually go into here, and if you want to, you can just do a draw debug sphere and just plug in like the world transforms of the start, control anchor, and end, and it will point them out in here. That's how I was doing it before, was essentially just showing, but I did it in a really ugly way, where if I show you the code, it will be very sad, so I will not show you that. It's very messy. But it's basically just copy and pasting of like this control anchor, draw debug sphere, plugging that into that, and then duration into that, and then that kind of stuff. Like that's literally all I'm doing. And then if I'm drawing a line from this point, or from this point to this point, you already had the location, so you just tell it start and end with draw debug line. You don't need to run it in the while loop. But yeah, hopefully this tutorial was informative. Let me know if I'm wrong on anything. I'd love to hear it. Yeah, have a great day.